Hello friends, this is Pratap N. Shinde. Welcome you all for the series of lecture of engineering mechanics. In last lecture we have solved some numericals of equilibrium of concurrent force system by using the Lamis theorem. Today we are going to solve some numericals by using the Lamis theorem as well as by using the condition of equilibrium. So let's proceed towards the today's class. So first numerical, in first numerical they have asked us determine the magnitude of force F1 and F2 so that the particle is in equilibrium. We have to find out in this numerical the magnitude of force F1 and F2 in such way that the system is in equilibrium. Okay, so come towards this figure. In this is the problem given. So in this problem the force F1 is given in fourth quadrant, which makes an angle of 30 degree with respect to horizontal. Force F2 is given which makes an angle of 20 degree with respect to vertical in counterclockwise sense is given, and the force 300 Newton is given which is horizontally towards the left. So let's say that this is a positive x direction, this is my negative x direction, this is positive y direction, and this is my negative y direction. So here are the how many forces are there? F1, F2 and let's say that 300 Newton. So only 3 concurrent forces are given, and we know that Lamis theorem is applicable for the 3 concurrent forces which keep the bodies in equilibrium. So we can easily solve this problem by using the Lamis theorem. So let's tackle this problem by using the Lamis theorem. Okay, so what is the Lamis theorem? So Lamis theorem is that force is proportional to the angle between remaining 2 forces. Okay, so here let's first take the force F1. So what is the angle between remaining these 2 forces? So this total angle is 90. So the angle, this angle we have to find out. This angle is 90 minus 20. This angle is 70 degree. Okay. Similarly, the angle between this force 300 Newton and F1 we have to find out. So this angle is 90 degree plus this angle 90 minus 30 60. So this total angle is 90 plus 60, that is 150 degree. This angle is 150 degree. Okay. Now when we have to take this force, then the angle between remaining 2 forces is this one. So this total angle we have to find out. So what is this angle? 90 plus 20 plus 30. So 90 plus 50, that is 140 degree. So thus we are able to find out the angle between all the forces. Now apply the Lamis theorem. What is Lamis theorem? Force upon the angle of remaining 2 forces which is equal to the another force upon angle sine of the angle between remaining 2 forces. So here if I take the force F1, the angle between these 2 forces is sine of 70, which is equal to F2 upon angle between remaining 2 forces is sine of 150, and the 300 force which is equal to 300 upon angle between remaining 2 forces, that is sine of 140 degree. So this is Lamis theorem. Now we have to solve this. So F2 is equal to 300 into sine of 150 divided by sine of 140. If you solve this, you will get this answer. F2 value is 233.36 Newton and F1 is 438.57 Newton. Thus we can able to solve this problem very easily within 2 steps by using the Lamis theorem. This problem also we can solve by using the condition of equilibrium also. So for that we have to resolve this force into its 2 components, and then we have to apply the condition of equilibrium. Just I will explain you how to resolve this force. Now this force which makes an angle of 30 degree with respect to horizontal is given. It's one component we can able to find out. So that is F1 cos of 30. This is horizontal component, and vertical component we can write down F1 sine of 30. So these are the 2 components of these forces. Similarly, we can resolve this force also in x direction and in y direction. So this force becomes F2 This angle is given with respect to vertical. We have to find out angle with respect to horizontal, that is 70 degree. So F2 cos of 70 and this component F2 sin of 70. So we can able to find out the its component in x and y direction also, and then after that we have to add this component and equate it to 0. So we will get the same answer by using the condition of equilibrium. What is the condition of equilibrium? So I will write down here condition of equilibrium. So condition of equilibrium is summation of f of x is equal to 0. I assume towards right is positive. Summation of f of y is equal to 0. I assume towards up is positive. So here we have to club all the forces in x direction and equate it to 0. Here we have to club all the forces in y direction and equate it to 0 and solve these two equations simultaneously. Definitely you will get the same answer. So choice is yours, whether you can solve by using condition of equilibrium or by using Lamis theorem. My suggestion is that when three concurrent forces is given, you have to solve this problem by using the Lamis theorem. It will save your time and definitely within 2 steps you will get your answer. Okay. So let's come towards the next problem. So what is the next problem is given? So in next problem, we have to find out the support reaction. Support reaction we have to be find out. So there is one sphere which is resting against the two wall. One wall is inclined at an angle of 45 degree and one wall is truly vertically is given. Okay. Now here we have to draw the free body diagram is the important in this case. Okay, so this sphere is resting against the vertical wall. There are the only 2 points of contact. Let's say this point is B and the another point of contact is A. Okay. So at the point of contact it will offer reaction on the sphere, so that these are the reactive forces. And what is the active force in this case? Only its weight. So what is the weight of the sphere is given 1000 Newton and we have to show its reaction offered by the support at point A and B. Now the reaction offered at point B is at an angle of 45 degree with respect to horizontal. How it will be 45? So it's simple. We have to construct the triangle. As we know that the reaction is always at an angle of 90 degree with respect to the with support reaction or at the point of contact. The angle made by the reaction at the point of contact is always perpendicular or 90 degree. As this angle is 90 degree, if we extend this line, here we have formed the triangle. So this angle is 90 degree, this angle is 45 degree. So what is the remaining angle? 180 minus 90 plus 45. So we can say that 90 minus 45. So this angle is 45. So therefore I have shown this reaction over here by using the principle of transmissibility. We can show the force anywhere on its line of action. Therefore this reaction is FB or RB, which makes an angle of 45 degree with respect to horizontal. Similarly, this point at point A, there is one reaction RA or FA, which makes an angle of 90 degree at the point of contact and it is truly horizontal. Therefore, I have shown over here the force FA in truly horizontal direction. Okay, and the weight is always acting through the CG vertically downward. So here again I have got the 3 forces. So we can able to here also use the Lamis theorem because it is problem of equilibrium. Here it is said that the system is in equilibrium. When the system is in equilibrium, then and only we can use the Lamis theorem. Okay. So again we have to apply the Lamis theorem. What is the Lamis theorem? Okay. So force FA. Let's begin with the FA. What is the angle between remaining 2 forces? What are the 2 forces? These are the 2 forces. So what is this angle? 90 plus 45, that angle is becomes 135 degree. The angle between the force FB and 1000 is 135 degree. Similarly, if we take the 1000 Newton force, the remaining 2 forces are FA and FD. What is this angle? this angle is again 135 degree. Okay, 90 plus 45, 135. Now if we consider this force FB, the angle between FA and 1000 is 90 degree. Okay, now we have to apply the Lamis theorem. So 1000, if we first consider the 1000 Newton, the angle between remaining two is 135. 1000 upon sine of 135, which is equal to FB upon sine of 90 degree, which is equal to FA upon sine of 135 degree. Okay, now this 135 get cancelled. If we compare first and third ratio, then you will get FA is equal to 1000 Newton. And if you solve first two ratios, so you will get the FB, that is 1414.12 2 Newton. So this is very simple. Here our aim is to draw the free body diagram. Here difficult part is the free body diagram. Once the free body diagram is over, just apply the Lamis theorem and you will get your answer within 2 steps. Okay friends. Okay, so these 2 problems are over. Now the next problem. What is the next problem is that they have asked us find the magnitude and direction of F so the system is in equilibrium. Here also they have asked us to find out the value of F and the direction of F. So what is the direction? Direction is nothing but the theta. That theta we have to find out. Okay. Now here if you observe that F 4.5, 7.5, 2.5, the 4 forces are there. How many forces? 4 forces are there. So is it possible to apply the Lamis theorem over here? No, it is not possible because Lamis theorem is applicable only for the 3 concurrent forces. Here the 4 concurrent forces are there. Concurrent means all the forces are meeting at a point, at a single point or the common point. Here let's say this common point is O, origin is the common point. So we are solving the problems of concurrent force system. Okay. So there are the 4 forces. So we cannot apply the Lamis theorem. So how to solve this problem? Yes, in this case we have to use the condition of equilibrium for the concurrent force system. What are the 2 conditions is there? Summation of f of x is equal to 0 and another condition is summation of f of y is equal to 0. So these 2 are the conditions of equilibrium for the concurrent force system, and in case of non-concurrent force system, along with these 2 conditions, summation of f of x is equal to 0, summation of f of y is equal to 0, along this condition we have to add one more condition, that is moment, summation of moment is equal to 0. This is for the non-concurrent, but here the case is concurrent, so only 2 conditions are available with us. So we have to solve this problem by using the condition of equilibrium. So by using the condition of equilibrium, we have to apply summation of f of x is equal to 0. So for that, what is the meaning of this statement? Summation of all the forces in x direction is equal to 0. So therefore we have to resolve the forces in x and y direction. Okay, let's begin with the force F. We have to resolve this force into x direction. So we have to make it horizontal. So what is its component? In x direction, F cos of theta, because angle with respect to horizontal is given, so this is F cos of theta, and its vertical component F sin of theta. Thus we are resolve this force F into, and both are positive because they are in first quadrant. Similarly, we have to resolve this force into its x and y component. This x component is 2.5 cos of 60 degree, because angle with respect to horizontal is given 60 degree. So this is 2.5 cos of 60. There is no need to write down the sign convention. Okay, here, and just this notation indicates that toward right is positive, and its vertical component is 2.5 sine of 60 degree. Angle with respect to vertical is given. Now this force 4.5, whether it is needed to resolve this force? Yes, it is not needed to resolve this force because it is truly horizontal. So you have to just add this force into x, f of x equation. Don't consider it into f of y equation. Okay, now third, this force 7.5 kilonewton. Now here the angle is given with respect to vertical is given. Okay friends, please take care while resolving this force. Okay, so first we have to find out its angle with respect to horizontal. So 90 minus 30, this angle is 60 degree. Okay, so we have to resolve this force into its two component. X component of this force is 7.5 cos of 60 degree, and its vertical component I will show by red chalk, this 7.5 sine of 60. Instead of cos of 60, you can write down here sine of 30, and here instead of sine of 60 you can write down cos of 30 also if angle is given with respect to vertical. Okay, this is the students are able to understand, they can write in this manner also, it is okay. Okay, so instead of that you understand, we have to find out the angle with respect to horizontal and then we have to resolve the forces. Okay, now by condition of equilibrium, what is the first condition? Summation of f of x is equal to 0. I assume the towards right is positive. Summation of f of x, what are the forces in x direction? First 2.5 cos of 60, 2.5 cos of 60, it is going towards right, therefore it is positive. Then second force minus 4.5, this force is in towards the left direction, so this is minus 4.5. Then third, this one is the third force, 7.5 cos of 60, it is minus because it is in towards left, therefore I have written here minus sign, so 7.5 cos of 60. Now come towards this force F, this is F cos of theta, it is going towards right or it is in first quadrant, therefore we can write down here F cos of theta, which is equal to 0 because it is condition of equilibrium. So if you simplify this, you will get equation F cos of theta is equal to 7. Let's say this is equation number 1. Now again applying the second condition of equilibrium, summation of f of y is equal to 0. So what is the summation of f of y? Summation of all the forces in y direction. So let's start from this force, 7.5 sine of 60. So it is going in downward direction, therefore it is positive or negative? Yes, it is negative because it is in vertically downward direction. So therefore 7.5 sine of 60, I have written over here minus sign. Okay, come towards the next force. This is 2.5, it is 2.5 sine of 60. It is again going in downward direction, therefore it is negative. So therefore minus 2.5 sine of 60, sine because it is vertical component. Now this 4.5 kilonewton force, whether we have to add this force into f of y? Yes, we don't have to add this force into f of y because it is given on the x axis or it is truly horizontal. So there is no need to resolve this force into y direction. So you have to add only this into only f of x equation. Now the third force, this one, f sine of theta, it is vertically upward, therefore positive or negative? It is positive, therefore plus f sine of theta is equal to 0. Now if we solve this problem, simplify this equation, you will get f sine of theta is equal to 8.65. Now equation 1 and 2 is known to us. If we divide 2 by 1, you will get the tan of theta. Tan of theta is equal to 8.65 divided by 7, and take the tan inverse of this, you will get the theta 51.01 degree. Thus we know the now direction. Direction is known to us. Now how to find out the magnitude? Substitute this value of theta either in equation 1 or either in equation number 2. Let's first substitute in one equation. F cos of theta is equal to 7. So f cos of, what is the value of theta? 51.01, and solve this. You will get the value of f 11.13 kilonewton. Okay, understood? Thus today we are solve the problems of concurrent force system, equilibrium of concurrent force system by using the Lamis theorem and by applying the condition of equilibrium. So always remember that if there are the three concurrent forces which keep the system is in equilibrium, then we can apply the Lamis theorem, which will make your problem very easy to solve. And if more than 3 forces is there, then we have to apply the condition of equilibrium for the concurrent force system. So you try to solve 1 or 2 numericals by your own. So today we will stop here. From tomorrow we will start the non-concurrent force system. So maybe parallel forces or non-parallel forces and reaction of beams. So thank you class.